Hello and welcome to lesson number 5 from Unit 6, Solving Problems with Quadratics in our Grade 10 Academic Math class. So this lesson, lesson 5, is the second of a two-parter on solving problems using factoring or the quadratic formula. So again, as I do at the start of these lessons, I like to sort of recap how far we've come in this unit. So this unit is obviously solving problems with quadratics. In our first lesson, we looked at how different versions of a quadratic relation, so standard form, factored form, and vertex form, they all can sort of be grafted onto different types of word problems. Then we looked at optimization questions for 2 lessons. The thing about optimization questions is that when they're in a word problem, they have a clue word like the word maximum or greatest or biggest or smallest or minimum, something like that, that indicates to you, it's sort of code for vertex. And for us to get to vertex, we need to get from standard form to vertex form by completing the square. The last lesson, and now this lesson we're embarking on now, these are word problems that we're going to be solving involving quadratics. The methods we have for solving, of course, are to factor or use the quadratic formula, again from standard form. So our challenge in these questions is first to recognize that it is a quadratic and what types of situations constitute a question that will be quadratic in nature for you to solve. Without further ado, let's jump in. So question 1 is a computer software company sells programs to students for $20 each. 300 students are willing to buy them at this price. For each $5 increase in price, there are 30 fewer students willing to buy the software. What price will generate $7,200 in sales, and how many programs will be sold? Okay, so for us, when we're looking at this is a revenue problem, and revenue problems are quadratic in nature in that we have some type of adjustment going on here. We have, maybe now's a good time to pause and just sort of write down what I already have here, which is our let statement and the revenue equation. Then we'll talk about it, and then we'll go about solving it. So hit pause now, give her a go, and then come on back. Okay, you've got it copied out. So the adjustment I was referring to is this adjustment of $5 increases and then 30 fewer students buying the software. So if we're talking about revenue, as I said the first time we did this in the last lesson, we're looking at price times number of items sold, which will result in revenue. Our price for the software originally was $20, and at that price 300 students were buying it. Then we have this $5 increase that we're seeing. This $5 increase, we don't know how many times it happens to get us to a sale amount of or a revenue, I guess, of $7,200. In the same way, matching that $5 increase, there will then be 30 fewer students who are willing to purchase this software. Again, how many times are we going to do that? At this point, it's unknown. That's actually what we're going to be solving for. And there is our variable, and we can see that multiplying this together will result in a quadratic. So we've generated our equation, we've created our let statement that says let n represent the number of price increases, and our target is to shoot for $7,200 in sales, so $7,200 in revenue. I also want to point out that we don't see the word maximum or biggest or anything like that in this question, which means we're not going to be completing the square, we are going to be solving. So let's get our standard form version of this thing figured out. So we're going to start by substituting in our $7,200, that is our target revenue. And now we're going to expand this out. So we have, I'm just going to be foiling the equation we have above, so 20 times 30 is going to give us 6,000. And then we have minus 600n and plus 1,500n. And then we have minus 150n squared. So that's our expansion. Now we're going to get all the terms on the same side and gather like terms, so I'm going to bring 7,200 over to the right side of the equation by subtracting 7,200 from both sides. So we're going to then have 0 equal to, so that was negative 150n squared. Whoops, not equals, sorry, that should be plus 900n and then minus 1,200 should give us our equation. So from here, we need to figure out exactly how much, what type of factoring we're going to do. So let's start by common factoring. I think all of these are divisible by 150. Just doing a quick check on that. Yep, they are divisible by 150. So that's where we're going to go first. So let's start by getting 0 equal to negative 150. Then we are going to have n squared minus, Now 900 divided by 150, that's going to give us 6. So we have minus 6n, and then this will be plus 1200 divided by 150, that's going to give us 8. Okay, so we've got this thing factored out. Looking at this, we can try the discriminant to see that if it's going to factor. We're dealing with fairly small numbers here, so I'm looking for things that multiply to plus 8 but that add to negative 6. So negative 4 and negative 2 will work here. I don't have to do the discriminant since figuring out if it's factorable is pretty straightforward. So let's go on to do our factoring. That will be 2 brackets here. Our first bracket will be n minus 4, and our second bracket will be n minus 2. So we have here our two solutions. They are going to be, if we sort of set each of these factors equal to 0, n minus 4 equals 0, and n minus 2 equals 0. By transposing negative 4 to the other side by adding 4, we have n equals 4. And by transposing negative 2 to the other side by adding 2, we're left with 2. Okay, so we have 2 answers this time. Let's see if either of them are inadmissible, because we're talking here about number of adjustments. Specifically, we're talking about how many times we can increase $5 to the price. So can we increase it by $5 4 times? Sure. Can we increase it by $5 2 times? Yeah, both of those are going to work. So for us now, we need to consider that there are 2 scenarios here. Scenario 1, I'm going to change up my color here. Scenario 1, where we have n equal to 4. And now referring back to the question, we're being asked what price will generate $7,200 in sales and how many programs will be sold. So we're looking for the price specifically. And as you recall, the price piece was going to be $20 plus 5 times 4 increases. So that's going to give us 20, I guess I can make those equals instead of colons. There we go, equals. So we have 20 plus 20, and that's going to give us a price of $40 for our software. How many will we sell at that price? Let's find out. So we'll call that the number, I guess, number sold. And that's going to be equal to 300 minus 30 times 4. I think that was our price, yep. And now we're going to work this through. 300 minus 120. We are going to then have 180 units sold. So that's kind of scenario number 1, where n equals 4. Our second, oh, I really ate a lot of space on that. Okay, we're going to do the other one, kind of try to squish it in here. Nope, didn't leave a lot of space anywhere. Okay, that's not great. let me move some things around here. Maybe I'll have room to actually write a therefore statement on here as well if I'm judicious with how I move this. Okay, let's start with our second scenario. And scenario number 2 is where n equals 2. So as we work the price, we see that it will be equal to 20 plus 5 times 2, and that's going to equal 20 plus 10, and that's going to give us $30. It's going to be the price of our software. The number is going to be 300 minus 30 times 2, squishing it in there. That's going to equal 300 minus 60, and that's going to equal 240 units sold. So both scenarios are going to work. The way that we can test this, of course, if we want to be sure, is to take our 40 and multiply it by 180, and that gives us our 7,200. And then we take our $30 price tag, multiply it by 240, also equals $7,200 price tag. So in response to this question, what price will generate $7,200 in sales and how many programs will be sold, we actually need to include both of these since both are viable. So we're going to write out our therefore statement. So therefore, the price, so a price of $40 with 180 sold, or a price of $30 with 240 units sold, will give revenue of $7,200. Alright, so there is our therefore statement. It's a little longer, obviously, because we're dealing with two viable solutions this time. So there we go. There's our solution for this first one. This is the first time we've seen one where our two possible answers both work out to viable solutions. It's possible. It's always possible, so make sure that you're checking that. I'm going to stop the video here. We're going to come back and do one more example, and then that's the end of the lesson, and we can head into the homework. Good luck, and we'll see you in part 2.